So in multiple sclerosis, there are two processes that occur simultaneously. And we are starting to understand these processes, how they interplay with each other, not only through animal models, which is perhaps the first window into our opportunity to actually look at pathophysiology of MS, but also as we start to deploy some of the markers, whether it's MRI-based biomarkers or clinical biomarkers. But you could summarize the process into two. One is acute inflammation, and the second process will be chronic smoldering inflammation. So in the acute inflammatory process, the current theory explains that there is this loss of peripheral tolerance by which potentially autoimmune or auto-reactive immune cells are not being destroyed or captured or inactivated. And then those cells are going to be, in a sense, looking for some sort of antigen that is going to trigger them. And that's where the Epstein-Barr virus theory plays an interesting role as being that external factor that perhaps serves as a trigger. And in that process, then once you have activated or autoreactive cells, they go through a process of amplification and peripheral proliferation that occurs in the secondary lymph node tissues, particularly in the lymph nodes. And when that happens, then there's this interplay between T cells, and B cells play a critical role as antigen-presenting cells, and also to help to amplify that immune response. Then the cells have to go through a CNS, which is a target organ. And once they go through the blood-brain barrier, they have to go through a secondary process of activation. In this process, that's where microglial cells play a role as perhaps some sort of antigen-presenting cells within the CNS, or perhaps just simply amplifying that response in the CNS. So that kind of like summarizes the acute inflammatory process.